Hi everybody. So today we'll move on to section 3. So how can we figure out the molecular structures? Basically, for example, we have a carbon monoxide and carbon dioxide. So how do we figure out what kind of bond? Is it a single bond, a double bond, a triple bond? So if you recall in section 1, we talked about single bond, double bond, triple bond, and pi bond and sigma bond. Those are the nature of a multi-bond. So so in this section, we'll talk about how we can figure out what exactly the bond between adjacent atoms. Right, so here's some kind of guidance questions you can look at. So what's the basic step to draw? Basically, we need to figure out the Lewis structures. The same as is also called Lewis electron dot structure. And there's another one called resonance structures. We'll get into detail what's the resonance structures. And there's some exceptions to octet rule. So we'll mention it, but it's not the focus of this class. Right. So in previous chapters, we talked about this molecular formula, just with the symbol of element with the number, superscript is the number of atoms. So this is one phosphorus bond with 3 hydrogen atoms. So the structure formula gives us exactly the bond symbol and the bond, show us bond. Remember we talked about some like sugar, although they have the same molecular formula, however, they could be different sugar because the bond, the structural formula is different, could be. So here the structural difference formula show us the exact bond. So this is the bonds, those are the bonds. Show us exactly what kind of bond, how the atoms link to each other. And Lewis structure kind of similar to the of structural formula. However, it's going to show the non-bonding electrons, also called lone pair. If there's a pair of electrons not shared between 2 atoms, you need to just draw 2 dots. It's the electron dot structure similarly. And there's some 3D molecular model. Both of those 3D kind of, one is a space filling. I don't use this much. I use a ball and stick often. So those balls means atom. In this case, terminal is hydrogen. This ball is phosphorus, and those sticks is a bond. Those sticks in the structural formula is those bonds. Right. So you guys need to write down the detail. How do we figure out this? How to figure out the structural formula? Because you guys take the notes, amaze me. Because you only write, probably some of you only write the first line, then assume you know everything else. But this give you the detail how you can figure out. First sentence means nothing. It's just a guidance step. So you need to write down the detail. As long as you know, I'm okay if you don't write down much, but I'm not okay. You just write 1 sentence, but you don't know this happens last year, right? People just run 1 sentence, but don't know how to figure out exactly the structural formula, right? You better write down every word. If you don't know how to rewrite in your own words, you better write down, copy every word, right? So the first step, you need to predict the location of certain atoms. So there's the two ways. One way, just look at the periodic table. These two ways are similar. One way is to look at the periodic table. So one closer to the left. For example, you have oxygen and nitrogen, carbon, right? So which one closer to the left? If you have nitrogen and oxygen, so nitrogen going to be central. This one going to be central. If carbon linked with nitrogen, carbon going to be central. If carbon linked with oxygen, carbon going to be central. So whichever one closer to the left. Or we can have a sulfur, the same way as down. If there's a lower sulfur linked to oxygen, sulfur going to be, this one going to be central, at center. Right? So whichever one to the left, whichever lower, down below the periodic table, going to be the central atom. So the nature of this one, you compare the electronegativity. So compare electronegativity. I just write short electronegativity. Smaller electronegativity. If you compare the number, you remember smaller is the center, is central. Right? Whichever one has smaller electronegativity going to be the central atom. So if you compare carbon smaller than oxygen, nitrogen smaller than oxygen, carbon smaller, the electronegativity is smaller number than nitrogen. So hydrogen is always terminal. Because hydrogen, you can only have 2 electrons, right? And hydrogen, remember we talked about one pair of electrons, 2 electrons can form 1 bond. Because hydrogen can only form 1 bond. It's always terminal. It cannot be central because it's only 1 bond. Central atom means multiple bonds linked to it. Hydrogen can only have 1 bond, so it's always terminal. So second step, we figure out the total number of valence electrons. For example, carbon monoxide, just add up valence, number of valence electrons. Carbon is 4, oxygen 6. So add up total number of valence electrons. So the next step, determine the number of bonds. Bonds. Basically, each bond, remember, so which section 1 we talk about each bond is 2 electron, right? So just total number of valence electron divided by 2. So it's the total number of electrons available for bonding. So 10 electrons can form 5 bonds. Right. So next step. So for example, we have we use a carbon monoxide. So it's 10 electron divided by 2. It's 5 bonds. Right. The next step, put a single bond between central atom and terminal. In this case, carbon is central. You just put a 1 bond, single bond between carbon and oxygen. Step 4. Number of bonding pairs. Right. So step 3, we figure out this 5 bonds. And step 4, we put the 1 bond there, right? So you need to subtract 5 minus 1. So there's 4 bonding 4 pairs of electrons left. Then put the lone pairs. Lone pair means this not not form any bond. So you just put a lone pair, one pair of electrons around terminal atoms. So there's 4 pairs, you need to put 4 pairs. I'm sorry. So put 4 pairs around the terminal atoms. So in this case, carbon is central. So put a lone pair terminal, in this case, oxygen. Right? For the lone pair, however, this is 1, 2, 3. So this 4 minus 3. We have another pair left. So hydrogen, remember we talked about hydrogen can only have 1 pair. So you don't need to put a lone pair around the terminal hydrogen. So the purpose of this one is to satisfy octet rule. So in this case, oxygen, you already have a pair shared. So this 2 electrons, you need to put 3 lone pairs there. So now the oxygen, this oxygen, if you count for this oxygen, now has 8 electrons. Right? So this the purpose for step 5 is satisfy octet rule. And then step 6, step 6 deal with the central atom. So now we need to figure out if central atom satisfy octet rule. Right? So the central carbon, now central carbon only have 2 electrons here. It's a bonding pair. So carbon need octet means 8. It's only 2. So carbon needs 6 extra electrons, carbon. So how do we satisfy this carbon? So we need to move the terminal lone pair electrons. We move lone pair electrons to the on the terminal to the central atom, form double or triple bond. So in this case, the shared electron can be shared between the central and terminal atom. So we increase the number of electrons for the central atom. So move lone pair. So in this case, we move lone pair form a double or triple bond. Move lone pair. Just remove this one, put it here. Remove this one, put it here. So there should be a triple bond, right? And remember when we do the step 5, we still have another 1 pair of electron left. Then we put this lone pair around carbon. So you need to recall section 1, carbon and nitrogen, those oxygen, sulfur, all those often form a double or triple bond. So what's the final structure here is we have carbon, triple bond, oxygen, lone pair around carbon, lone pair around oxygen. So last step, check your structure, check octet for all the atoms. So we check carbon. So it's 3 bonds, each bond is 2 electrons. So here's 6 electrons here. And the lone pair is 2 electrons. The total is 8 electrons for this carbon. Now we check oxygen. Same thing, 6 electrons shared. And here the lone pair 2 electrons. So oxygen 6 plus 2, oxygen 8 electrons. So now both carbon and oxygen has 8 electrons, satisfy octet. So this should be the structural formula for carbon monoxide. So what if we have polyatomic ions, something like polyatomic ion, like nitrate ion, right? So for polyatomic ions, it's similar. The procedure is similar to when we deal with a neutral atom. However, you need to add this extra electron to the total number of electrons available, like valence electron. So for the positive ions, cation, you need to subtract it. So in this case, nitrate ion is negative, means there's extra electrons. So what we're talking about here, so nitrogen has 5 valence electron, right? Oxygen has 6 valence electron. However, 3 oxygen, you multiply by 3. So when we figure out total number of valence electrons, 5 for nitrogen, 6 for oxygen, because you need to add this one into it. So plus another 1. So this is the total number of valence electrons available. So we need to add this 1 for this charge. So this is the difference for the ions and neutral atom we just talked about in the previous slide. Here's the example. So we need to figure out the Lewis dot structure for ammonium NH3. So what do we need to know? Just follow the steps we just talked about. First step, figure out the total number of valence electrons available. So nitrogen 5. So if you forgot how to figure out valence electrons, you need to review the previous chapters. So basically, you look at periodic table, look at group number, use group number to figure out the number of valence electrons available. Is equals to group number, or group number minus 10. So nitrogen 5, hydrogen 1 valence electron. So total is this 8 valence electrons. So next step, you figure out the bonding pairs. So don't forget that each pair is 2 electrons. So just divide this 8, this number, put it here. This is the total number of valence electrons divided by 2. Total bonding pairs or pairs of electrons. So there's 4 pairs of electrons. Right? So next step, just put the single bond. So put single bond. Put single bonds between central atom and terminal atom. So don't forget hydrogen always terminal, because hydrogen can only form 1 bond. Hydrogen can only form 1 bond. It cannot be central. So if hydrogen is central, how is linked to another atom? Right? It's no way. So hydrogen has to be a terminal. So just put a single bond between the central, in this case nitrogen, and the hydrogen. Remember the previous step we have figured out there's 4 pairs. However, there's only 3 pairs. You need to put so the next step, we put the lone pair. So next, because we figure out there's 4 pairs, we only put the 3 pairs around nitrogen. So we put 1 pair around the nitrogen. So we just draw this lone pair, 2 dots around nitrogen. And the last step is check octet. So now we need to check octet, right? Check hydrogen. So each hydrogen can only have 2 electrons, just 1 bond. So all those hydrogen has 2 electrons. So hydrogen is good now. Then we check this nitrogen. So this nitrogen, each bond has 2 electrons. It's 2, 4, 6, plus is 2 dots, 2 electrons, 8 electrons. So 6 plus 2, 8 electrons. Right? So then now it's, all the atoms, all the hydrogen and nitrogen has 4 octet. So it's this structure should be the right one. So all the atoms satisfy octet. Here's another example. Try to figure out carbon dioxide, CO2. Try to figure carbon dioxide, CO2. So first thing you need to do is figure out which one is terminal central, right? So, because carbon, nitrogen, oxygen, carbon is at the left of oxygen, so carbon is the central. Or the electronegativity of carbon is smaller than oxygen, so carbon is central. So carbon is central atom. So the oxygen is terminal. Next step, figure out the total number of valence electrons. So carbon is 4, oxygen 6. However, we have 2 oxygen. This is carbon dioxide, right? So 2 oxygen. So we add up the total 4 plus 6 multiplied by 2, have 16 valence electrons available. Next step, figure out how many pairs. So 16 divided by 2 electrons per pair. I have 8 pairs of electrons. Right? So we have 8 pairs. Don't forget we have 8 pairs. Then, because this first step, we figure out carbon is central, oxygen terminal. Then we put this 2 single bonds between carbon and oxygen. Right? Then we have figure out this 8 pairs and 2 pair used. We have 6 pairs extra. We need put these 6 pairs around the oxygen. Right? So put the 6 pairs around oxygen. So just draw these dots around the oxygen. So this 2, 4, 6, another 2, 4, 6. So this one pair, 1, 2, 3, 4, 5, 6 pairs. 6 pairs around the oxygen. Right? So we have 6 pairs. We put 6 pairs there. So there's 0 pairs available for carbon. Then we check octet. Then we check octet for central. Then we check octet for carbon atom. Because carbon in this structure, carbon need 8 electrons. However, here only 4 electrons for carbon. So we need to move some lone pair around oxygen to oxygen between oxygen and carbon. You need to move this one between oxygen and carbon to form double bonds. So if we move this here, we got here. So now carbon, central carbon has 4 pairs, 8 electrons. So last step, don't forget to check octet for all the atoms. So we check terminal oxygen. Check this 2 terminal oxygen. This each pair 2 electrons. It's 2, 4, 6, 8. Same thing, 2, 4, 6, 8. So both oxygen has 8 electrons. Then we check central carbon. Carbon has 2, 4, 6, 8 electrons, right? So then now this all the carbon oxygens has a satisfied octet. So this should be the Lewis dot structure for carbon dioxide. Here's another example with polyatomic group. Phosphate PO4 3-. In this case, you need to add these 3 electrons to the total number of valence electrons available. Right. Same thing, first step, we need to figure out which. Usually, so phosphorus and oxygen, which one is a central atom? So in this case, have nitrogen, oxygen, phosphorus, right? So remember, talk about which one left hand, go left hand, or which one is below, going to be central. So in this case, it's a diagonal. So it's so from nitrogen, this one go left. So nitrogen is central. Nitrogen to phosphorus. So phosphorus central to nitrogen, central to oxygen. So phosphorus has to be central atom. An alternative way you can check the electronegativity. Phosphorus is much smaller than oxygen. Not much smaller, smaller than oxygen. So in this case, phosphorus central. Phosphorus central. So 4 oxygen is a terminal. Then we figure out the total number of valence electrons. So 5 for phosphorus, 6 for oxygen. We have 4 oxygen. Don't forget this. You need to add this 3 electron, 3 minus charge, and 3 extra electron to the total number of valence electron. So add up total is 32 electrons available. Right. So we have 32 available. Divided by 2 electron per pair, we have 16 pairs. So next step, we put the, because here we already figure out phosphorus central atom. So we put a phosphorus in central and oxygen in terminal. Then we put the single bonds between phosphorus and oxygen. Right. So what we have now is here. Right. So this we use the 4 pairs. We figure out this 16 pair total. So we have 12 pairs available. We need to use these 12 pairs, put around the terminal oxygen. So this is lone pair electrons. Right? We need to put the lone pairs around oxygen. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we use 12 electrons pairs. So we put 12 around oxygen. So we have no extra pair of electron available for central phosphorus. Right. So then we check octet. We check oxygen because this all oxygen similar structure. 3 lone pair plus 1 bond. So this each bond 2 electrons. So 2, 4, 6, 8 electrons. Oxygen. So oxygen is good now. Then we check central phosphorus. So each bond 2 electrons. So 2, 4, 6, 8. So now all the 4 oxygens and central phosphorus satisfy octet. So this one should be the red Lewis dot structure. Right. So we have this kind of alternative way to figure out. It's kind of similar. So whichever one you want, you can. This alternative way to figure out the structure. So first thing is same thing. First step, same. Figure out arrangement, just like N, O, 3 minus. We figure out a random which one, basically figure out which one is central, which one terminal. Just compare use the periodic table, which one left hand or down below going to be the central, or you compare electron activity. In this case, nitrogen is central. Determine total number of valence electrons, the same as what we taught. This step, same. Probably I still use carbon monoxide, is easier. Arrangement, carbon going to be central. In this case, total number of valence electrons, carbon 4, oxygen 6, total number of valence electrons 10, total number of electrons required. So step 3 is going to be different. So this one is just try to figure out the total number of electrons required to get 8 electrons. Basically, try to figure out how many electrons we need to satisfy octet for all the atoms. So in this case, carbon need 8 to satisfy octet, oxygen need 8 to satisfy octet. So total going to be 16. So we need 16 electrons to satisfy octet for carbon monoxide. Right? Step 4. So total number required minus total number available. So in this case, required is 16. Total number available from step 2. Here, step 3 minus step 2. It's the 10 minus this one. So we got 6 electrons. Right? So this we need 6 extra electrons. So basically, this is the shared electrons. So we need to have 6 electrons shared between carbon and oxygen. 6 shared, going to need 6 shared between carbon and oxygen. Then put the shared pairs between carbon and oxygen. 6 pairs divided by 2 is 3 bonds, right? So we need to put 3 bonds between carbon and oxygen. Then distribute the rest of valence electrons. Because we have 10 valence electrons, we already put 6 there. Minus 6, we need to put 4 extra electrons. This 10 is the total number of valence electrons we have. Then we put 3 between, we put 6 between carbon and oxygen already. So we need so we have 4 valence electrons left. We need to put on a carbon and oxygen. So we need to put the lone pair on carbon, lone pair on oxygen to satisfy octet. So the last step, check octet, is very important, right? You check the structure. So check carbon, it's 8 electrons. Then we check oxygen, 8 valence electron. So this should be the structure. Right, here's the example. HCN here. So remember, we talk about carbon, hydrogen is always terminal, so we don't need to worry about hydrogen. So carbon and nitrogen, which remain central. Just check periodic table, carbon, nitrogen, carbon on the left-hand side, so carbon is central, right? Carbon is central. Or you can compare electronegativity, carbon is smaller than nitrogen, so carbon is central. Then we figure out number of valence electrons. Nitrogen has 5, carbon 4, hydrogen 1. This is a valence 5. This is a valence electron each atom has. So nitrogen needs 8. This for octet. Right? Those numbers for octet. Nitrogen need 8 to satisfy octet. Carbon need 8 to satisfy octet. However, hydrogen only needs 2 to satisfy octet. So we add up total valence electron available. So it's 10 available. We add up total electron to satisfy octet. So it's 18 in order to satisfy octet. So the difference, so what do we have, what do we need minus what do we have divided by 2. So 18 divided by 2. We have 4 bonds, this shared pair electrons. So we have hydrogen, carbon, nitrogen. We have 4 shared bonds. So we need to put because hydrogen can only have one bond, so we put one bond between carbon and hydrogen. Another 3 pairs put between carbon and nitrogen. So it's 4. It's 1 here, 3 here. The total is 4 shared pairs. The last step, you need to check octet. So in this, no, we need to put there's another extra lone pair electron. So remember, we figure out this 1, 4, 5. If I add up total, you have 10 valence electrons. However, only put this 1, 3 bond. So there's 4 bonds. 4 bonds equals to 8 electrons, right? So I have 10 valence electrons, but we only put 8 around hydrogen, carbon, and nitrogen, a shared bond. We have so this is the difference between two numbers is 2 electrons. We need to put 2 electrons on the terminal atom first. So hydrogen, you cannot put extra electron on hydrogen. So put this lone pair on nitrogen. So last step, check octet. Check this hydrogen. It's 2 electrons. It's good. We check the nitrogen. 2, 4, 6, 8. So it's nitrogen good. Then we check this carbon. 4 bonds, 8 electrons. So carbon is good. So now all this hydrogen, carbon, nitrogen has a valent, a certified octet. So this exact Lewis dot structure for this compound. So here some sometimes it's useful. So hydrogen can only form 1 bond because hydrogen can only form 1 bond always because hydrogen can only have 2 electrons. Okay? So hydrogen can only always form 1 bond. Oxygen 2 bond, nitrogen 3 bond, carbon could form 4 bond. So this just depends on the carbon, nitrogen, and oxygen is the group 4, 5, 6A. Because octet means 8, so oxygen has the 2 extra electrons to satisfy octet. Because 2 if you put 2, can form 2 shared bond. The similar nitrogen 5 need 3 to satisfy octet. They need 4 to satisfy octet. That's why carbon can form 4 bonds, nitrogen can form 3 bonds, etc. So the same for oxygen. Right, here's some practice problem. Right, so when you take notes, you need to do those practice in your notebook when you send your notes to me, right? Just do those in your notes. Try to do the practice of those. Right, so right, so there's another covalent bond called coordinate. What that means? You use carbon monoxide. We've been talking about this. So remember, carbon has 4 valence electrons. Oxygen has 6 valence electrons. Right. So this for this illustration purpose. So this 4 valence electrons from carbon, so different color. So those 6 valence electrons from oxygen. So there's the 2 electrons from oxygen shared with carbon. So this we can use oxygen, put an arrow. This means this pair of electrons is from oxygen shared to carbon. So this is called a coordinate covalent bond. This just give you some concept. So it's this is not focus for this class, because carbon can only have 4 valence electrons. I mean, why there's extra electron between carbon and oxygen? Because it's oxygen provides extra pair of electrons. So this pair, extra pair, called coordinate covalent bond. Right. So this last part is a resonance structure. Resonance structure means one is several possible Lewis dot structure, Lewis structure. Those possible Lewis structures called resonance structure. So in this case, double bond, you can the position of double bonds change. We could put on the top, on the left-hand side or right-hand side. So these 3 structures not exactly the same. Can different, the position of double bond different. However, all those 3 is possible structure. So those structure called a resonance structure. Actually, none of those. I'll explain on next slide. So none of those exactly structures. Actually, it's a combination of those 3 resonance structures is more closer to the real situation. I'll show you on next slide. Right. So this resonance structure, actually, none of those 3 bonds actually single or double bond. Is kind of in between single double bond. Those I will say maybe 1.3. Remember, top bond order is not a single bond order 1, double bond order 2, is single bond double bond. All these 3 bonds probably 1.3, 1.4, something in between single bond and double bond. These 3 bonds. So this structure more closer to the real structure. Right. So in some case, we have some exception to octet rule. This means some atom can have more than or less than. So it's not 8 in a real structure, not 8 electrons, right? So not 8 electrons. Sometimes more than 8, sometimes less than 8. So this is called exception. So in this case, nitrogen dioxide, this nitrogen dioxide is a central nitrogen has an incomplete octet, means less than 8 electrons. In this case, it's 2, 4, 6, 7. So this central atom has 7 electrons. It's not 8 electron octet. So this most time happen to the group 5, like nitrogen, phosphorus, because they have odd number of electrons most time. So because this molecule have odd number of valence electrons, because if they're odd number, octet means 8 is the even number. So odd number sometimes could have cannot satisfy octet, so it has incomplete octet. So if you you still can use the procedure we talk about, try to figure out use the procedure, two different procedure we talk about to figure out a Lewis dot structure. So we're going to end up with a one R number on a central nitrogen. So boron is another boron. If you count this structure, boron has 6 electrons, right? So it's not it's not archetype. For boron group 3 has 3 valence electrons. Boron is R number, so you form a structure B. Boron hydride, boron trihydride is the structure has 6 electrons in structure. It's not an incomplete archetype. It's another example. So if we have a structure has a incomplete archetype, less than 8 electrons, with another structure with a lone pair of electrons, they can form a coordinate covalent bond. Remember, I talked coordinate in the carbon monoxide. It's coordinate. So this nitrogen can donate this electron to form coordinate. So this one is coordinate covalent bond. So this can form a bond between boron and nitrogen. It's a coordinate covalent bond. Because all this can happen because boron has an incomplete archetype, only 6 electrons. And nitrogen has a lone pair. So nitrogen can donate this extra pair to boron, has an incomplete archetype. Right, sometimes we can have a expanded archetype. However, this only happened to the period 3. So only for the element with the d orbital. Okay, it's here, d orbital. Because d orbital empty. So phosphorus has empty d orbital. For phosphorus, 3d is empty. No electron with 3d orbital. However, it's available. It has d orbital, but the d orbital is empty. So d orbital can have an electron in d orbital, so accept the electron into d orbital. So it's from expanded archetype, something like that. So in this is expanded, so it has a 10 electrons for central phosphorus. So those exceptions for archetype rule is not the focus for this class, but I'm going to show you, you need to know it. Right, here's the example for the expanded octet, xenon tetrafluoride. So we know this xenon is a noble gas. It already has 8 valence electrons, right? How noble gas can form. So we talk about before noble gas very stable, it seldom form a compound, but the only rare case with a very, so phosphorus, remember we talk about has highest electron activity, has highest ability to obtain electrons. So this noble gas can only most time form a compound with a fluorine. So we can figure out this structure. Xenon has 8 valence electrons, fluorine has 7, and there's a 4 fluorine. The total is 36 valence electron. right? 36 divided by 2 pairs, so we have 18 pairs. So in this case, right? So we can compare. Remember we talked about fluorine is the highest electronegativity is the highest. So fluorines are always terminal. Fluorine is always terminal because it's highest electronegativity. So in this case, xenon is central. So xenon. So fluorine is terminal. So you put 4 pairs. So we have 18 pair minus 4 pair. We have another 14 pair. We need to put a lone pair around the fluorine, around the 4 fluorine. Right, we put a 14 pair around the fluorine. So this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we use a 12 pair, 14, we use 14 pair minus 12 pair. We have a extra 2 pair now use. So we need an extra 2 pair on the central xenon. Then we check octet for terminal first. For the fluorines, all fluorine had 8 electrons, so fluorine is good. However, in this case, because we have exception expanded octet, so for xenon, it's not 8, it's more than 8. So it's 2, 4, 6, 8, 10, 12. So it's a 12 electron. It's called expanded octet. So this one is very toxic because it's highly reactive because it's not octet. It's so it's not very reactive, not stable, because it's xenon is not in the octet. Right, it's all about section 3. Here are some questions, essential questions. So the basic step you need to recall, we have so we talk about the two different procedures. Whichever one you want to use, either one is okay. Resonance structures is when there's a multiple possibility, you can put a double bond, triple bond. Exception octet rule, we can have incomplete or expanded octet. Right, that's all for section 3.